We should be live. So, hello everyone and happy Thursday. We're back with another live stream. Ellie in Space here, joined by Dr. Phil Metzger. A lot of people requested another live stream with you, actually, while I was interviewing other people. So, they wanted you back. So, thank you for joining us again.
Glad to be here again.
Definitely. And so, we have some people tuning in from Germany. We have someone from New Jersey, and you guys, hot off the press, SpaceX just about 10 minutes ago dropped this video. So I'm just going to play it for you. I think this is your first time also seeing it, correct?
Yeah.
So this is a long duration test fire of a Raptor while gimbaled 15 degrees. And I believe this was out at McGregor, which I would like to go out there at some point. I live here in Texas. But just thought I would share some breaking news with you guys. Anything unique about this that you see other than the angle?
Yeah, I'm guessing, I don't know why they have a gimbal, maybe just testing the gimbal mechanism. I don't know, but it does lift it above the ground a little bit, so it's less interaction with the ground. One thing I notice is you can see what we call the jet extinction length. The rocket exhaust coming out of the nozzle is supersonic, and it mixes with the surrounding atmosphere. So you get this supersonic core surrounded by the turbulent gas. And so you can see by the end of the jet, it's real turbulent. But the supersonic core inside of it gets narrower and narrower until it reaches the length, the jet extinction length. You can also see a little bit of the plume expands after it comes out of the nozzle, and then it expands too far, and then it pinches off a little bit, and then expands again. Those are called mock discs or mock diamonds. The nozzle is a little bit not matching the local atmospheric pressure, but it's pretty close. So it looks like a sea level nozzle.
Now, and they didn't specify whether this, I'm guessing it's Raptor 2. I know they're working on version 3, but any idea?
No, I haven't heard.
Okay.
Yeah, I was just trying to do some very crude calculations with Raptor engines today, in fact.
Really? Tell us about that.
Yeah, so I'm just using publicly available data like what I got off Wikipedia. But I'm trying to calculate the dynamic pressure of the plume. So if you could put your hand in front of that flame without it burning off, how much pressure is it putting on your hand?
Right.
Because that was the pressure it put on the launch pad. And calculating if the launch pad cracked, from the first Starship launch, we think it probably cracked. And once it cracked, it drove gas into the crack and built up pressure underneath the launch pad. And so I'm calculating what pressure was building up. And I'm calculating it was about 2 meganewtons of pressure, hang on a second. That's not right. That newtons is force. It's not megapascals, is it? Might be. Anyways, I don't have it open right now, but it's comparable to a volcano.
Wow.
Yeah, it was actually similar to the pressure. Yeah, it is similar to the pressure that would build up inside of a volcano when the volcano explodes. So hang on just 1 second and I'll have that number. Well, anyways, yeah, I was trying to calculate how fast the particles blew up into the sky. And so I had to calculate what the pressure built up underneath the launch pad would be, and it's like, wow, it's right in the range of volcanoes.
Wow. So you're still, and that's something that I also wanted to, because I did a live stream yesterday with Dr. Scott Walter, and he's like, well, what are you going to talk about with Dr. Metzger? And I'm like, well, you've been doing, research since this first Starship launch back in April. So I kind of wanted to know if there was any update from those samples that you collected and or had people help you collect, if there was any update to your research.
Yeah, so we sent the samples to Jason Hafner. He's a scientist at Rice University in Houston. And so he did some analysis of the minerals in the sand. And oh, by the way, the pressure is 2 megapascals. So
Wow.
it'd be about 2.5 megapascals right at the exit of the Raptor. So I'm estimating about 2 megapascals under the launch pad, and that is definitely right in the range of volcanoes. So
Wow.
if the gas mixed with the sand after it blew out, if the gas was about 5% of the weight and the sand was the other 95%, then they would have gotten to a velocity of about 250 meters per second. And anyways, so, but yeah, we sent those samples to Jason Hafner. And when we had the samples, we measured their sizes and their shapes so that we could do the ballistics modeling. That's what I'm doing right now. And then we also did infrared and visible light spectrometry, where you just look at the light bouncing back off of the particles and compare it to a reference material. And so some people sent us pieces of the fondag and pieces of the ordinary concrete and pieces of what looks like limestone that blew out, as well as beach sand. And so it turns out that the particles that fell in Port Isabel matched the beach sand. They did not match any of the types of concrete.
Right.
And
Interesting.
so, yeah, there was no concrete in that. And so we've concluded that the fracture of the launch pad in that volcanic explosion did not bust it up into little tiny pieces. And so the only little tiny pieces, the only significant fraction of the small stuff that landed in Port Isabel was all beach sand. It was there was an insignificant or zero fraction of little bits of concrete mixed in there.
So this
So
seems like pretty good news for, because I know some people are worried about, well, how long is the hang up going to be for the next launch with environmental concerns? So this seems pretty promising.
I think so. Yeah, I mean, it was definitely no health hazard. The stuff that fell in Port Isabel, it was just like having a big wind on the beach and some sand blew up onto the ground, around your house. So it was basically the same thing. The sand was not a breathing hazard. It was coarse enough that it would not go up into your nose. It would not stay suspended like a dust cloud. It would just fall to the ground. And it was not any exotic chemicals. It was not even concrete. So it was just beach sand. But then what Jason did at Rice, he used Raman spectroscopy, which can actually identify the minerals. And so he found out that it's mostly quartz, which is beach sand, with a couple other of trace minerals, which are characteristic of the Boca Chica beach sand. And so we got positive diagnosis or identification that that's what it is.
Interesting. Yeah, because I mean, this research has been going on, gosh, almost 4 months since the launch. That's crazy.
Yeah, it takes time. We had to get access to the instruments, and everybody's working on a variety of projects, not just one project. So it took a while. But I want to show you something. See the shirt that I'm wearing?
Yes.
When I was at NASA, I was a part of the Lunar Surface Systems team, and we created technologies to operate on the lunar surface. And then later on, when we co-founded the Swamp Works at NASA Kennedy Space Center, we remade the shirt and we changed it to just surface systems because we also wanted to include Mars and asteroids. But so this was a Swamp Works shirt, but it was based on a patch from NASA's lunar surface program. So as a thank you gift to all the people who sent samples, I got some patches made, and this is the original lunar surface systems, because we're going to use this data about launch pads exploding to help develop lunar launch pads.
Wow.
And we actually have some funding right now to try to solve the problem of gas buildup underneath a launch pad. So So we're actually working on it, and the Starship data is a case study that's actually very helpful for the research we're doing for lunar surface systems. So I'm going to send these out pretty soon once we finish the research and get the paper ready to get published.
Well, and so that's the other thing that I saw you tweet about or post, I don't know what you call it now on X. But I wanted to play this video because I also haven't talked to you since we have the new edition of The Deluge. Again, this is from Everyday Astronaut, Cosmic Perspective, great footage. But I want you to kind of explain the two different, I mean, very different scenarios here and how this is going to benefit the upcoming second test flight.
Okay, yeah. So well, let me ask you, what is the biggest difference you see in those two pictures?
Oh, the color of the smoke.
Yeah, the color, that's right. That's the biggest difference. And the color difference tells us that in the top picture, that rocket plume was picking up sand and dust.
Yeah.
But the bottom picture, it's not. And that's pretty remarkable. You know, you got this ginormous rocket with all these Raptor engines blowing, and it's not picking up sand or dust. Isn't that pretty wild?
Yeah.
And I mean, of course, it didn't. Neither one of those pictures did the launch pad fracture, because that was the upper picture is the test firing, and the launch pad survived. So in the top picture, when it's picking up the sand or the dust, I believe that's around the sides of the pad. So the plume is blowing out, and as it goes out, it's picking up all this material and training it into the gas flow. And all those particles are opaque to light. The bottom cloud is just water vapor and carbon dioxide, because the LOX methane engines produce water vapor and carbon dioxide. The carbon dioxide is invisible, but the water vapor forms tiny droplets. And so the tiny droplets, they don't absorb the sunlight or the light, the sunlight, not significantly. They mostly just scatter the sunlight. And so the sunlight goes into the cloud, bounces around all directions, then comes out random directions. And so the whole cloud is white. And that's because it's made out of just water droplets. The top cloud, though, it's got water in there because the same rocket exhaust, but it also has all those sand and dust particles which are absorbing the sunlight, absorbing it, making it dark, and letting some longer wavelengths get through, and therefore it has this orangey, reddish, yellowish color. So that's the biggest difference that I see. And I was pretty astounded when I saw this, because I didn't know that the deluge system on the launch pad would be so effective at breaking up the ground jet of the plume so that it can't even pick up sand anymore. So that was pretty cool.
So, you know, the recent booster test wasn't perfect. It ended prematurely, and 4 of the engines went out. So do you have hope that you know, this will be enough? Or do you think that they're like technically ready yet, or they still have work to do?
Well, I don't know what they're doing inside SpaceX, you know. So all I can say is well, all I can say is that what they've described, what they're doing, and what they've shown certainly can work, you know. So if their engineers have done the engineering, and I know they're good engineers, then it should work. I don't have any reason to doubt their design. I mean, I think water-cooled steel is a really cool concept.
Right.
And as long as they designed it so the water deluge is enough to keep it cool, and if they designed the pressure of the, you know, shooting the water out so that it can overcome the pressure of the plume and, you know, continue to shoot water out, then as long as they did that engineering, then I think it should work fine.
Well, maybe you'll know the answer to this question from Okie Oakman. Will the booster have adaptation plates for the variations of Starship or dedicated boosters?
Yeah, I don't know the answer to that at all.
Yeah.
Yeah, I'm sorry, I can't.
Well, if you don't, then I don't. I did want to ask you, just because I've been asking, I asked Zach Golden with CSI Starbase yesterday. And so the other recent news that we heard is that tentatively around August 31st, I think there's no way. I've had people message me and they're like, okay, I'm going to start planning my trip. I say no. So what do you think about that as a date? Do you think that's realistic?
I mean, people make jokes. They call it Elon time, right? Because Elon will
Yeah.
say, in 10 years, we're going to have a city on Mars or whatever. And I've heard people say this, like, well, Elon time is usually optimistic. It usually takes longer, but in the end, he always does what he says he's going to do. So I don't know. Could be delayed just because that's what happens.
But don't you think August 31st? I mean, that's way too soon for, I guess they filed their mishap report, but it's still ongoing. What has to change? And
I don't know. I, yeah, that's now okay. So that's government lawyerly stuff. Um,
yeah,
yeah.
the fun stuff.
I have no idea. Yeah, it depends. It depends what the politicians do because it's important for NASA to get these flights going. This is our lunar lander, at least our first one. And if we want to get to the moon and put humans back on the moon again, and this time, what is it NASA always says? The first woman and the next man to land on the moon or to
Yeah.
walk on the moon. If we want to do that, we got to get this launch going, right?
Yeah.
And so, and there are politicians that are sensitive to that, and they understand the importance. And so, if they are greasing the skids, as they say in government work, if they're greasing the skids, then hopefully it'll flow more quickly and they can get through this process. But I really don't have any insight into what's going on there.
Right. Well, we know that Gwen and Kathy Leaders is now down there, so who knows how much that is influencing the process. Thank you, Bimmer Geezer, as always, for the generous super chats. He wants to know if NASA uses the latest Starship lunar lander, the engines will be some 15 plus meters above the surface. Will it still kick up debris?
Um, well, so I have done work for SpaceX on this with a non-disclosure agreement, so I can't give you an answer, but I can just tell you in general terms, okay, just talking general physics, when you mount and thrusters higher on a rocket, it dramatically improves the situation. You get a real big reduction in the plume effects.
Okay.
So like there was a lunar lander being developed partway by Masten Space Systems and the United Launch Alliance. It was called Zeus, spelled with an X, Xeus. You can look it up. There's stuff online about Zeus, and it was the same idea. Well, it was a Centaur upper stage, so it had an engine at the end of the cylinder, but it was going to turn over sideways and have thrusters on the side to land horizontally. And so I told the team, let's mount those thrusters as high as we can on the vehicle because it does deeply reduce the plume effects. So anyways, Starship is a very tall vehicle, and so you've got a lot of room to move those nozzles up.
I knew I saw Masten Space Systems. Someone actually asked if you've done any work with Masten Space Systems and sprayable launch pads for the moon.
Yeah, I was on that project. Matt Coons was the PI, principal investigator on that project. He now works for SpaceX doing the Plume stuff for SpaceX. So
Interesting.
yeah, so Matt's a good friend, and Matt innovated this idea of injecting aluminum dioxide or aluminum oxide of some kind. I don't know the details, but aluminum oxide into the rocket nozzle as you're landing on the moon. So you're spraying in this aluminum oxide, it melts into droplets, and the rocket exhaust blows it to the surface and it splatters and builds up a thick surface. So then you can come down lower and land on it without spraying the dust. And so Matt got funding from NASA to study it. I got a really funny story about this. I feel like I might have already told you this story. Did I tell you a story that had to do with guns and people out in Mojave, California?
That I think I remember that. That sounds pretty
Okay.
specific.
Well, so I was my job on that project was to figure out these molten drops that are spraying down in the rocket exhaust. What happens to them when they hit the lunar surface? And I was worried they were just going to burrow deep into the dust, and you're not going to build up a launch pad. And so if that's the case, we would have to overspray, much, much more until you finally beat down all the dust and cover it. And so we wanted to shoot particles into simulated lunar soil and dust, but we needed them to go several hundred meters per second. And that's the speed of a bullet. So I was trying to figure out what device can we use to create projectiles going that velocity. And the only thing I could come up with was a gun. And so I thought, well, this is the stupidest question ever. But I called campus police and I said, is it possible to have a gun on campus for research purposes? And they're like, yeah, it actually is. You got to follow the process. We have a process. I mean, you're a researcher, right? You got to do research. So I worked out the whole process where we were going to actually purchase a handgun and shoot bullets into simulated lunar soil and measure how far the bullets go in. But then there was a deal killer. The problem was there was no way for us to dispose of the gun at the end of the project because we weren't allowed to sell a gun. And we didn't really know how to destroy the gun. And I didn't want to get stuck keeping a gun in a safe forever. So I called up my friends at Maston Space Systems they're out in Mojave, California, which is, cowboys out there in the desert.
Yeah.
And I called them up. And I'm like, yeah, I couldn't get the gun to do the research. And they're like, oh, you just need a gun? Oh, we got guns in our cars out in the parking lot. And so an hour later, they sent me videos. They went and they got a gun out of their car and they were standing up on a ladder shooting a shotgun down into the lunar soil. It only took them an hour to do that.
Oh, wow. I feel like I would have maybe wanted to keep that gun for like the memory of the experiment. I don't know. Not your thing?
Well, it's just bureaucracy, I would have to maintain it and maintain documentation, because it's a safety thing on campus.
Oh my gosh. No, I did not remember that story. Now, Ross wants to know if Lunar Starship is not ready in time for a crewed landing on the moon for Artemis 3, as hinted by NASA recently. What do you think would be a worthwhile alternative mission objective?
Okay, if it's not ready to land on the moon for Artemis 3,
which they kind of hinted at that pretty recently during a press conference that they might need to change like their whole plan.
Right. So are you wondering, is the question, will it still be a Starship landing, just not a crewed landing?
The question is, if we don't land on the moon for Artemis 3, what should we do instead?
No landing at all. Yeah.
I think so.
Right. So they could do a mission at the gateway altitude, because this would be a crew mission in Orion. And so they could just take the crew up to near rectilinear halo orbit, which is a big elliptical orbit. So if this is the moon, it's an orbit that's like a big ellipse that goes like this. And so they could go into that orbit and just have the crew experience that for, I don't know, a week and get data on their biology, their physiology, radiation, because that is more radiation exposure than what they get at the space station, for example. So it could be a shakedown cruise. The last time we sent Orion into that orbit, or around the moon, there were no crew on board. So it could be the next step by having crew in the spacecraft. So that would be a valuable mission. But I really want us to get on the surface.
Yeah.
I think we need to get to the surface as quickly as possible.
It just seems like the timeline is really slipping. I mean, I didn't think the proposed timeline was really realistic in the first place, but
No, when NASA announced it years ago, they were saying by 2024. Is that what they said?
I think so, which is, it's a
Yeah.
shame. It really is. It's like, man, you really think that at this point we could have done it. We could
Well, I went on record at that time and said, yeah, that's not reasonable. We're not going to make 2024. But I'm glad we set 2024 as the date because it lights a fire under everybody. So I'm really happy for that date. But I never believed we were going to make 2024. 2028, that's more doable. So, but at the time when I got some calls from the press, and so I made some statements that got printed. Um, so what I did was I looked up how long did it take us to build the Apollo lunar module from the time that Kennedy announced we're going to do it until we did it. And it was like 7 years that they had to build the lunar module and test it, So, I mean, it takes time, even in Apollo, it took 7 years to do that.
Yeah. Yeah. But still, still. Well, you know what? While we're talking about the moon, I was stalking your Twitter because why wouldn't I? And I came across this interesting post about very cleverly named regolith, not regolith, regolith. So explain this
Yeah.
idea and why you think it's, you know, not just beneficial for the moon, but also potentially for Mars.
Yeah, so that was the White Pill newsletter, which is, I understand it's a popular newsletter. A lot of venture capitalists in the San Francisco area read it.
Hmm.
And so they interviewed me, and we talked a lot about mining the moon to make rocket fuel and why I believe that that is going to be economically viable, why it will be able to outcompete launching rocket fuel from the Earth. And so they just coined the term regolith because you're using regolith, the dirt, the regolith is the dirt,
Right.
to make rocket fuel, and the rocket fuel provides lift to lift things off the moon.
It's perfect.
I know, it's brilliant. So, but anyways, yeah, it was kind of fun. It was a fun interview, and they quoted a few things that I thought were well chosen quotes, quoted from the paper that I wrote. One of the things I said in the paper was about comparative advantage. That's a concept in economics. Suppose America, United States, can make socks cheaper than, let's just say, some country, make up a name. Well, let's just say Czechoslovakia. I don't know. The Czech Republic. So let's say we can make socks cheaper than the Czech Republic, and we can make shirts cheaper than the Czech Republic. But the difference in the cost that we can make socks versus shirts, we actually have a bigger savings making socks than we do shirts. So it turns out, even though we can make shirts cheaper, if we buy the shirts from the Czech Republic at a higher price and sell them socks, then we end up getting more of everything cheaper, and they do too, because we each play at our strength, even though their strength may be weaker than our weakness, because everybody's engaged and everybody's playing to their strength. Everybody ends up better off, and this you can prove this mathematically. So it's and so it doesn't matter if we have an absolute advantage over the Czech Republic in making shirts, because they have a comparative advantage in making shirts, because their cost of shirts is cheaper. The difference of shirt versus sock is less for them than it is for us. So they have a comparative advantage. So in my paper, I said, you don't really need an absolute advantage to make rocket fuel on the moon. You just need a cheap comparative advantage. So the question is not, can the moon launch rocket fuel cheaper than the Earth can launch rocket fuel? The question is, is it more lucrative to launch communication satellites than to launch water from the Earth?
Right.
Because if they make more profit launching communication satellites, then they're better off buying the water from the moon, even if it's more expensive. And so So I wrote a paragraph about that in the paper, and I sent it to an economist who focuses on space research, and he said, when he replied to me, I had like 5 or 7 people read the paper before I sent it to a journal for peer review. And he sent the paper back to me and said, this one paragraph right here is the most important part of the paper. Everything after that is just frosting on the cake. So
do you have the paragraph? Can we read it?
Oh, I can look it up. Hang on one second.
I mean, now I'm intrigued.
Well, do you have the tweet from the White Pill newsletter
Yeah,
there?
let me
They quoted it in the tweet too, at least one of their 2 tweets.
is it this it needs only a comparative advantage
That's
part?
it. Yeah.
Okay, so you wrote, it needs only a comparative advantage since launching rockets entails a significant opportunity cost in buying propellant in cislunar space between the Earth and the Moon from a lunar mining operation may be comparatively less expensive than losing the opportunity to launch a more lucrative payload. In general, Earth launched propellant does not compete against lunar propellant. It competes against the value of other payloads that can be launched from Earth. Makes sense.
Yeah. So a different business leader read that paragraph and he said, well, I'm not sure if I really believe that because right now SpaceX is building an oversized rocket and they're going to have a glut of launch capacity. So they're not going to be topped off. There's not going to be enough other satellites or spacecraft that they can launch on Starship. So because there's just too much launch capacity.
Right.
And so he said in the near to midterm, they may prefer to launch the propellant themselves. So when I modified my paper before submitting it to the journal, I acknowledged that, and I discussed the fact that, well, in the long term, it benefits SpaceX to be prepared to buy propellant in space because in the long term, the space economy is going to change. The low launch cost of Starship and other vehicles is going to create new business opportunities for things to do in space that are currently not being done because they're just too expensive. Well, and so that's called elasticity. There's going to be price elasticity of demand. And so when the price of launching goes down, the demand for launching will go up.
Right.
And so in the long run, the comparative advantage argument is valid, I think.
Well, this is interesting to me too, because obviously we know Starship and methane go hand in hand, and methane is something, that you can find on Mars. However, I think this is part of your paper, say it would be equally useful for Elon Musk to use liquid oxygen and liquid hydrogen for Starship so that he can forego the hundreds of propellant launches he'll need to send to orbit to make the trips to Mars.
Well, so yeah, you have to. We're going to split some hairs here. I'm going to part this carefully. So I don't think it would be worth them redesigning their architecture to switch over to hydrogen and oxygen because they've already invested so much in methane and oxygen. And for Mars, for long trips to and from Mars, methane is more storable than hydrogen. It doesn't boil off. And so there are advantages to using methane instead of hydrogen. But it turns out that oxygen is about 80% to 83% of the mass of a liquid hydrogen, liquid oxygen engine. And so if you're just selling the oxygen and throwing away the hydrogen, then the economics are only going to change by like 27% from what I said in that paper. And a 27% error is like really tiny at this level of research. We're talking about factors of 10, 100, 1,000. And so if you're saying, well, it's 0.83 instead of 1, that's such a tiny error that we can neglect it at this point. So I think the arguments are still valid, even if SpaceX only gets the oxygen from the moon, right, and brings the methane from Earth. But when they start building the ability to go to and from Mars, they're going to probably have to build some new hardware at some point. Um, I mean, once they start trying to send 1,000 starships to Mars every 2 years, um, there's an opportunity that they might scale up, build bigger transport vehicles that go back and forth. And so at some point, they could consider switching to hydrogen and oxygen. And then one last point is that there are people who look into making methane on the moon. I don't think it's really the greatest idea because there's not that much carbon on the moon. There is a little bit of carbon in the lunar ice, but it's such a small amount that it's really too precious to just burn into rocket fuel. So, but there are people who talk about trying to make methane on the moon.
Interesting. I don't think I've heard of that concept proposal. So what else have I not? I'm trying to think. We talked a few weeks ago. What else is new in your world that you want to chat about?
Well, let's see. The Prime 1 mission is it's a payload that's going to go on the Intuitive Machines lunar lander. I don't know what the launch date is. I've heard rumors. Some of my friends at the European Space Agency told me they were hearing rumors that it might get delayed. I don't know if that's true or not, but it's supposed to launch sometime in the next year, and it's going to carry a payload called Prime 1. That payload will have a drill. It'll drill down into the lunar ice and then drop the drill cuttings into a pile. And then there's a mass spectrometer that looks at the vapor coming off of that pile. And so we're trying to calculate by the amount of vapor how much ice is in the pile. So that's the part I'm working on. I'm writing software to try to model that so that during the mission in real time, they'll be able to say, aha, there's 5% ice or 3% ice. So I'm working on that. That's kind of fun. Like I mentioned, I'm right now doing the Starship ballistic calculations. I've got a paper I'm almost finished on. Yeah, this is interesting. So I will break the news here. People watching your podcast will get this first. But for about 20 years, I've been trying to solve the equations of when the gas blows over the soil, how fast does it lift the dust into the gas? Like we just saw that video where the top one was orange and the bottom cloud was white. The top cloud was lifting dust up into the cloud at a pretty quick rate. And the bottom one, the cloud stays white. It's not lifting dust into the jet.
Right.
Okay, so you see the color difference, very distinct. So the question is, when you land on the moon, how fast is it lifting dust up into the rocket exhaust? Because that tells how much it's going to sandblast things off in the distance. And we want to know how much damage will it cause. So therefore, how far away do you have to land from your other assets? And after 20-something years of doing the research, I finally have the complete equation. And so I'm writing a paper. But the thing is, when you look out the window of the lunar module, if you've ever seen those videos of landing on the moon, the Apollo landing videos, I mean, if you want to look it up, you can find it on YouTube. There's videos of Apollo 16 or Apollo 15, all of them landings, but you can see the dust blowing. And so what I did was I took those videos, I cropped a square out of the middle of the window, and I just averaged how bright that view is. And then if you plot it, as the lunar module is descending, how bright is it? You can see that the brightness starts going up when the dust starts blowing, and it increases, and it has a certain curvature. So so what I did was there's one unknown parameter in the physics, and so I fit the curve, fit the theory to that data from Apollo, and it makes a perfect fit. I mean, I couldn't have been more happy with how perfect the theory fits the data. But here's what's cool about it, okay? So we've got a validated theory, But later in the Apollo landing, that dust cloud gets opaque. It looks like that top picture right there. It
Mm.
gets so dark that you can't see through it anymore. And so we can't tell how much dust is in the cloud. All we know is it's too much to measure. Well, now that we have a theory, we can actually predict that curve all the way to landing on the moon. And you can add up how much total soil got blown. And what we found out is we used to think it was about 2.5 tons of soil got blown in each Apollo landing. The new estimate is between 20 and 50 tons of soil got blown in each landing.
Wow.
So it's about 10 times more than we used to think it was. And so the problems of blowing dust on the moon is actually about 10 times worse of a problem. So
No.
yeah, so I'm trying to rush this paper out because I think it's really important and the community needs to see it pretty quickly. But you heard it first. So
Okay.
that's the result.
That sounds, I mean, because I've heard that regolith is just so difficult to deal with. So yeah, that sounds like not, I mean, not great news. That's crazy that, you know, you've been working on this for so long, but maybe not the best of news.
No, yeah, it's I mean it is what it is. It just means that we're going to have to build landing pads. We're going to have to put blast barriers to block the spray of dust to keep it from hitting sensitive hardware. There's things we can do, but it just helps us to understand the degree that we have to do those things. Like landing farther away is another option. And so we need to make sure that our blast zones are big enough so that we're not going to damage hardware that doesn't have blast barriers. So there's a whole toolbox of things we can do to fix the problem. But it's better to find out now than to find out later after you've damaged stuff on the moon.
Right. And I will say, so I think this comment is a little bit misinformed. You just gave environmentalists something to talk about how much debris is spread around for a launch test. No, this is referring to landing on the moon, correct?
Yeah, it doesn't apply to Starship. And besides that, like I was saying a few minutes ago,
Yeah.
that bottom picture there, those are nice white clouds. There's
Yeah.
no dust being picked up in that picture.
Right.
So
Right.
that deluge system apparently solves it completely at Starbase. I mean, if we could only have water deluge on the moon,
Yeah.
water is too precious on the moon. We're not going to use it like that.
Well,
So,
now that we know this, I mean, what do you think absolutely has to be something they plan for?
I'm sorry, say that again.
Now that you've discovered this and that the problem is actually kind of worse, what do you think you want to get this paper out and you want to get this information out. So what do you think is like the first, plan of action to combat this?
Well, it doesn't really matter that much until you start landing things near each other.
Okay. Interesting.
So yeah, so I mean, it can potentially damage spacecraft that are orbiting the moon because the rocket exhaust is going about 3.5 kilometers per second. And so the finest dust particles get up to that speed. So, but the lunar escape velocity is way below that. And so it's actually blowing things completely off the moon. So the dust that gets blown off the moon goes into orbit around the sun. And so it does go up past all the orbital altitudes in orbit around the moon. And so you could sandblast things that are orbiting the moon. Um, at the distance of NASA's Gateway, I'm estimating about 10,000 particle impacts per square meter. Sounds like a lot, but it's actually not bad because these particles are a tenth of a micron in size. And like 50 microns is a human hair. So we're talking like 1/500th of a human hair,
Wow.
tiny particles. And they're so small. And also, the gateway because it's so high above the moon, it's actually going very, very slow. And the dust that gets blown off the moon is slowing down the higher it goes. And so it turns out that the particle impact velocities are actually pretty low, pretty slow. And so such tiny particles going that slow don't do much damage. It's pretty much negligible damage, but it's something we just want to be aware of in case you have sensitive instruments.
Right.
But if you have a spacecraft in low lunar orbit, like say 50 miles above the moon, that velocity you're going is really fast, and the ejecta is still going fast. And also, the ejecta hasn't spread out much. And so, if you fly through the ejecta, if you just happen to come by at the wrong time, right as the ejecta is going up, you fly through it, it's still not going to destroy your spacecraft, but it could abrade the optics beyond what you wanted. So I mean, we're talking like 2% degradation of your optics. 2%, it's only 2%, but if you've got a scientific instrument, you don't want 2% degradation of your optics. So it is something we have to be aware of even for orbit, but the way you handle it in orbit is by timing the landing. So you don't land right when the spacecraft is going to fly through the ejecta. So you can handle that. We call it COLA, collision avoidance, COLA. So whenever you do a launch off the Earth into orbit around the Earth, sometimes in the middle of your launch window, there will be a COLA. And that COLA means we can't launch during that little cutout, because if you did, we would come too close to some orbital debris. And
Okay.
so we manage COLAs all the time. The difference here is that instead of the spacecraft going up and the debris is already up there, this time the spacecraft is already up there and the debris is coming up from the moon. So the roles are reversed, but it's still the same kind of deal that we can handle operationally. But if you're going to land two things on the surface of the moon close to each other, that's when it starts to be a big deal. And we're not yet planning that. We're talking about outposts on the moon, but we haven't baked into the architecture the details of these outposts yet. And so there's still time to adjust our architecture.
What do you think about this question from John? Would an aerospike engine work better on the moon since you can take off different and the bell shape can be adjusted?
Well, I'm not an expert on rocket engines. I mean, I'm more of the expert on the dirt side of it.
Yeah.
But my understanding is that the reason an aerospike engine works is because, that spike in the middle is like half of a bell. It's half of a rocket nozzle. The other half is missing. If you're in the Earth's atmosphere acts as the other side of the bell. If you're in vacuum, I guess there is a loss of thrust, but you could still do it. So I'm just kind of talking around the problem because I'm thinking out loud. But I think what's going to happen is I'm not sure you're going to. I think there may be an efficiency loss when you use one in vacuum. So you would actually have to have more thrust rather than less to support yourself on the moon. But whether it's more or less, you're still blowing rocket exhaust onto the lunar soil. So I'm not sure if that would help or not.
Well, this is another engine related kind of comment. I think what we need are sophisticated rocket engines that do real time fuel conversion in flight in space upon initial mining of the resources.
Yeah. So I worked on a lunar mining architecture once. I called it Aqua Factorum, which means water maker. And I did include the conversion to rocket engine. It wasn't converting it inside the rocket engine. I guess the question is saying the rocket engine converts it from water to rocket fuel. I didn't work on that concept. I was looking at having equipment on the ground at the mining site that cleans up the water and then it splits it into hydrogen and oxygen, liquefies it, so it's liquid hydrogen, liquid oxygen, and then you use it in a rocket. Now, once I did work on a water propulsion system. We called it WINE. Honeybee Robotics gave it the name. WINE stood for The World Is Not Enough. I don't know exactly why they came up with that name. but but I was like, okay, we're turning water into wine, because taking the
Yeah.
water off the asteroid and making wine, making rockets that propel themselves using water. So, but yeah, in that case, we weren't electrolyzing to make hydrogen and oxygen, which is a method of storing energy. Instead, we were just simply using the water as reaction mass, and then we were heating the water, just directly heating it. So you can heat it with like a toaster oven coil or microwaves or any way you want. So you've got to have an energy system, and you're dumping heat into it, boiling the water, making steam, and blowing steam out the back of the rocket. And so in rocketry, we use something we call the specific impulse to describe how efficient a rocket engine is.
Right.
The higher the specific impulse, the better. So a LOX methane engine might have a specific impulse of like 350 seconds, I think. Whereas a liquid hydrogen, liquid oxygen engine might be around 450. So steam propulsion is only going to be around 160. So it's a lot less efficient. But we argued that there are cases where having such a simple system is still worth it. Even though, I mean, you have to mine more water because you're going to burn the water faster. But such a simple system makes it worthwhile. Now, there's another guy who studies using water, and that's Joel Sercel. Joel has a company called Transastra.
I know him. I met him at the Ascend conference last year in Vegas, which I will be going to again this year in October. I don't know if you're going.
I'm not planning on it, but Joel is a super smart guy, one of the smart people. There's like a handful of people that I would say are the smartest people I know, and he's in that group.
Wow.
But he's won close to or maybe equal to the most number of NIAC projects of anybody in the world ever. NIAC is NASA Innovative Advanced Concepts. So he's won like 6 or 7 or 10 or I don't know.
Wow.
I got one, so I'm happy I can die now. But Joel has so many, I don't even know how many. But one of his was this thing called Omnivore. And Omnivore is a system that you put anything in it and it burns it as rocket fuel. Not literally anything, but you could dump water in it, and the water could be dirty water. It could have all kinds of chemicals mixed in it, and it's okay. Omnivore uses it, and it uses a special heat exchanger that can dump energy into it super fast. Joel invented a new kind of ceramic that will operate at a super high temperature without melting and transfer heat really fast. And he patented this ceramic that he invented. So that's an example of developing a rocket engine that can use water directly.
Interesting. I should interview him on the show. I did a quick interview with him at Ascend, and I made a video about it. But now I think he should come on the show.
Yeah, really interesting guy. Works on a lot of cool stuff.
Yeah, and he's in California, I think. Right?
He is.
Yeah.
Yep.
Yeah. Well, great. Well, I think we'll keep it to an hour. I've had some people say keep your live streams a little closer to an hour. So that gives us about 5 more minutes. So if people want to ask any lightning round questions to Dr. Metzger, I do appreciate you, giving us some of your time, because it sounds like you're working on a million things at once. Okay. Here's one from Al. Zach Golden, my friend, CSI Starbase channel, wants to know if the purpose of long duration Raptor engine test firing is known. Any SpaceX info put out on the purpose of test firing? Not sure if you had another one.
No, I don't have any inside knowledge on that. I just know that in general, for rocket engine testing, they want to get time on the engines in order to flush out problems. So that the reliability gets better.
Great.
A test program, the longer you test it, you can eventually flush out more and more problems and get the reliability a lot higher. So I imagine that's probably why they're doing it.
Gregory wants to know, will you be looking at the same issue for Mars or asteroids?
Yeah, we absolutely are.
Okay.
When Curiosity rover landed on Mars, they lowered it down from the sky crane. So the sky crane was hovering, and they had cables, and they lowered the rover down, and then they let the cables go, and the rover could drive off, and the sky crane just flew away and crashed intentionally. And there were two purposes for that. The original purpose was to reduce the mass of the vehicle, because having these cables was less mass than having a mechanism that the rover can drive off. And so it actually reduced the mass. And that was the original reason. Most people don't know that was the original reason for it. But second reason that they very quickly decided is another benefit, another reason to do it, is the plume problem. Because like I said before, putting the thrusters higher makes it better. But there's one problem on Mars that we don't have on the Earth or the Moon. The problem is that there is an atmosphere. The atmosphere focuses the plume into a long jet. The Moon, it spreads out. There's no atmosphere. So the plume spreads out, and that reduces the effects. The Earth, there is an atmosphere, and so it focuses the plume into a narrow jet. But on the Earth, the atmosphere is 100 times denser than on Mars. And remember at the very start, I talked about the jet extinction length in that first video that you showed? Well, that length depends on how thick the atmosphere is. And so Earth's atmosphere mixes with the jet and tapers it off at a certain length. On Mars, jets go a lot farther because the atmosphere is so thin. So even with the sky crane way up above the surface, those jets from the plume went all the way down, touched the ground, dug craters in the ground, and then the gas had to come, like if it blows gas in at an angle, then makes a hole, then the gas has to come back out of the hole, shooting right back at the vehicle. And when it comes back out of the hole, it carries rocks and sand with it. And so it was actually blowing sand back at the vehicle as they were lowering the sky crane. And so the top of the rover got covered with rocks. And one of those pieces of gravel apparently is what hit the aft wind sensor and broke a wire. So they lost one of the instruments on Curiosity because of the plume effects during landing. So this is with a small planetary, relatively small lander for a planetary science mission. When you start landing really big rockets on Mars, it's going to be a big problem. And so we are looking into that.
Oh, wow. I do want to say thank you again for another super chat from Bimmer Geezer. Ellie, I die with happiness every time you smile. That's very kind of you to say. And people are also suggesting, and I think we talked about this a little bit last time, of doing an interview with Robert Zubrin. So I don't think I've heard back from him yet, but maybe we can coordinate that, because it seems like, a good idea.
He's really interesting, very passionate. One time he gave a talk at the New World Conference in Austin, Texas, and it was like listening to a Baptist preacher on fire. Just he was so animated. And he gave a talk called "The Case for Space," why we have to go to space, and it was like the best space talk I've ever heard. And I let him know afterwards. I was like, "Man, Bob, you were on fire. That was amazing."
Yeah. Yeah, Zubrin would be a slam dunk. I don't know if they're still doing that, because I live in Austin now. I'd love to go to that. I tried to look it up. They might not be doing it.
I don't know. We were going to do it again this year, but I haven't heard from Rick Tumlinson lately, so I'm not sure if we're still on or if something happened that put it on hold.
Well, you guys heard it here. My breaking news is I'm going to try to get a hold of Robert again. But thank you, Dr. Metzger, as always, for sharing some of your time and insights with us, and for sharing your breaking news.
All right. Well, it was great talking with you again. And thanks to all the audience for the great questions.
Yes. Awesome. Well, thank you guys so much. I'm glad you enjoyed it. Have a great rest of your Thursday.